Hello everyone, I am Anmol Vora and you are watching this video on optical character recognition. OCR is my project topic for the course Pattern Recognition at University of Florida. I will start with a brief presentation on the topic followed by a demo of the implementation I studied. So what is OCR basically? It is the electronic conversion of images of typed, handwritten or printed text into machine encoded text. It is widely used as a form of data entry from printed paper records to digitized text that can be electronically edited and searched. For 60 years, handwriting and computers have coexisted, and yet a machine's ability for recognizing human handwriting is imperfect. This makes it an interesting and challenging research area of image processing and pattern recognition. As said before, it is an upcoming research field wherein we need to cope up with everyday complexities. So latest research is to develop new methods to overcome the complexities of the writing styles. With the advent of mobile devices equipped with cameras many times more accurate and higher resolution they had years ago, the ability to scan text with a camera for later is a commonplace. And if an image is of written notes, it would be impossible to search for it. And that's why there's a need for a machine to do it for you. So the basic system includes recognizing a character from a given image, matching the features against a set of defined patterns that we have, and then giving the output as desired. This is a pictorial representation of a typical OCR system. The input document is fed into a scanner so as to get the document image. The image undergoes the process of analysis and enhancement if need be. Depending on the algorithm used, characters or words are then recognized. A stage of contextual processing could be the next step, and it could be then again followed by recognition of characters or words. These OCR results are then fed into an output interface to be used by the users via a consumer application. The solution can also be stored in a database or a text file. So recognizing a character is mostly dependent on the quality of the scanning and segmentation steps. If a character segmentation incorrectly slices a character into half, and if then the network is trained with that value, it will not be able to recognize full versions of that character, or it might incorrectly recognize other characters. Likewise, its output must be something we can get a character from. There is a wide variety of data we use to analyze an individual character, from as simple as like a ratio of pixels from the top half to the bottom half, or analyzing histograms of the image, or contour analysis of the binary image, as I have done in my project. So as described in the previous slide, there is a basic pipeline approach to this problem. Lines, words, characters are segmented and then recognized individually. The recognition analysis is based on a model which may be any of the following: matrix matching, fuzzy logic, structural analysis, feature extraction, or using artificial neural networks. I have implemented the project in OpenCV, and I have also researched about Tesseract, which is Google's open source OCR engine, and that will be demonstrated at the end of my presentation. Moving on to all these processes, first is matrix matching. This converts each character to a pattern within a matrix and then compares the pattern with the index of known characters. It works well for monotype and uniform single column pages. Next is fuzzy logic. It is a multi-valued logic that allows intermediate values to be defined between conventional answers like yes, no, true, false, or black and white. It is used when there is uncertainty and distinct answers are not involved. Next we come up to structural analysis, which identifies the characters by examining features like shape, subvertical and horizontal histograms. Then is feature extraction, in which each character is defined by the presence or absence of certain features, which is developed on the basis of a lot of research. So the For example, there is height, width, density, and other character traits. Lastly, there is neural networks in which sample of the pixels in each images and matching them to a known index of character pixel patterns is done, and this is a very upcoming research. Now we come up to the performance evaluation. So computer-based OCR systems have gone a long way since their introduction in early 1950s. Although their productivity, robustness, and accuracy have improved much since then, but the OCR systems are still far from being perfect, especially regarding their accuracy. When we are given a paper document, one can scan it to produce a digital image that can be processed by the OCR program and whose output is the document's text presented in a machine readable form, like a text file. To estimate the OCR accuracy, the OCR output can then be compared to the text of the original document, which is basically our ground truth. Since there are multiple ways to compare the OCR output to the ground truth, we have multiple ways to define the accuracy. When the original document's text is available in an electronic format, a computer can evaluate the OCR accuracy by comparing the document's source file with the output file. When the document's text is not available, a fluent native speaker of the language can type the correct text into a file in order to provide a ground truth. Alternatively, one can resort to having a native speaker look and visually compare the source document and the corresponding output. This process may be as casual as identifying misspelled or missing words in the OCR output, and it can follow a rigorous path of computing a formal OCR accuracy score. Thus, the accuracy is measured can greatly affect the reported rate, and accuracy expression takes into account number of correct, inserted, deleted, and substituted items with respect to the original text. And in the image below, you can see the character-wise and word-wise calculations of recall and precision as numbers as researched by some scientists working in this field. So hundreds of OCR systems have been developed since their introduction in the 1950s, and many are commercially available today. Commercial OCR systems can largely be grouped into two categories. One is task-specific reader. They handle all specific document types. So some of the most common task-specific readers process standard forms, bank checks, and credit card slips. For example, a bank check reader may just only scan the courtesy amount field, and a postal OCR system may scan the address. So such systems emphasize high throughput rates and low error rates. The second category is the general purpose page readers who are designed to handle a broader range of documents such as business letters, technical writings, and newspapers. A typical general purpose reader works by capturing an image of a document page and then separating the page into text versus non-text regions, applying the OCR to the text regions, and storing the non-text regions separately from the output. Most of the general purpose page readers can read machine written text, but only a few can read hand printed alphanumerics. So as you can see in the figure, there's a company accumulated benchmark results of commercial OCR engines that are available as of now, with tested on different corpus. In my implementation, I have used a basic digit recognition system using OpenCV, and I have achieved 100% accuracy, and this was because the digits were of same size and kind. The contour finding method was used as a basic approach, and just because it was a first level hierarchy, maybe that's the reason I got such an accuracy rate. Also, the white spaces and other special characters, alphabets, were ignored. There are a number of factors that make OCR difficult. One is poor document quality of the originals, noisy low resolution multi-generation image scanning, insufficient image processing, poor segmentation into recognition tokens. And for all these sectors, a lot of research is going on. Some of the considerations for future scope include adaptive thresholding, which is basically taking care of illumination factors, making baselines perfectly straight, looking into special case font dependent spacing, working parallelly with outline approximation and feature matching, and continuously improving the dictionaries, that is the word list that we use to train our data set. So to conclude, there are a lot of methods available that I studied and theoretically evaluated. The techniques which provide better results are generally slow, and the faster ones provide inefficient results. I implemented digit recognition system using OpenCV. I trained the machine by manually inputting the correct digits and then tested on the basis of KNN method of classification. I explored TensorFlow, which is an open source library for machine intelligence, and I also researched about Tesseract, which is a free software engine for character recognition and learning. These are some of the references I took while making this presentation. Next is a demonstration of my project. So now I will be telling you about the implementation. These are my two Python files, program train, which will train the dataset, and test to test the dataset. These are the two images that I've used for my analysis. I run my code on IPython, and while running the training program, I get this image file in which I have to manually enter the digits. So as you can say, my program has identified that this is a digit with a red boundary, and I now need to tell it that it's a 7, 4, 4, 4, 5, and similarly for every digit that it has recognized. I can go on and label all my numbers and thus test them. As you can now see, the training is complete and the two data files have been generated. Now I'll go ahead and run my test file. As you can see, these are the outputs generated. So the one I see in forefront is the output file, whereas this was my input image. And if you want, you can see that both these images are identical. There was a dot here which hasn't been recognized by the classifier. All the digits have been named correctly, and this shows 100% accuracy. And though this isn't the best model, but through this project I have learned a lot about pattern recognition and OCR and OpenCV. So that's how my project works, and hope you liked it. Thank you for watching the video.